This is a question of JEE 2013. We have to find limit in this question. For a belonging to real number, the set of all real numbers, a not equal to -1. If limit n tends to infinity of this whole thing is equal to 1 by 60, then what is the value of a? And this is a multiple choice question having more than one option correct. So either one option may be correct or more than one option also may be correct. So first of all, how to attack this problem? This denominator terms looks pretty simple because this is nothing but an arithmetic progression. So I can find the sum of this thing. This also 1 to the power a, and it has got n terms, and here I have got n plus 1. So first of all, my problem is to how to reconcile this n and n plus 1. Because once if I make it somehow n, then I can use some formula of definite integral using limit as sum. But how to make this n plus 1 as n? Now that is very simple. If you see, I have to find limit n tends to infinity, and when n tends to infinity, there is practically no difference between n and n plus 1. Because suppose I tell you it is 10,000 billions and 10,000 billion plus 1, so there is practically very small difference. But I can use it like this also. So what I will do, in this denominator I have been given, so let's write this denominator first, n plus 1 to the power a minus 1. Okay, so I will divide it by n to the power a minus 1 and multiply it to the power a minus 1. I am doing everything in denominator. So what will happen? I will get this as n plus 1 by n to the power a minus 1. Now if I take limit n tends to infinity, what is this n plus 1 by n? This is 1 plus 1 by n to the power a minus 1. Now 1 by n will be 0 for limit n tends to infinity. So this is 1 to the power a minus 1, which is equal to 1. So effectively this term will be removed and I will get n to the power a minus 1 in my denominator. So this is the first step. How to? So I have made use of this step, that limit n tends to infinity, n plus 1 by n will be 1 to the power a minus 1. So instead of n plus 1, I will start writing now n to the power a minus 1 here. Okay, so let's remove this thing. Okay, now what is these things? These things, if you want to find sum of these, this is na plus na, there are n times na, so that will be n times na, because na is here, there are n such terms, plus you have 1 plus 2 plus 3 plus till n. So what is sum of first n natural numbers? N into n plus 1 by 2. So basically I have here n square a plus n square by 2, that is I have a plus half n square plus I have one term of n by 2. Same thing you can find using the formula of a sum of arithmetic progression also, in which the first term is na plus 1, number of terms is n, and common difference is 1. So if you use that formula, that is sum of arithmetic progression, you will be n by 2 into first term 2a plus. So if you use that formula also, you will get this same thing. This is very simple, so I am not doing that. So ultimately we have got here this thing, na square plus n square plus 1 by 2. So I have taken n square common, so I will write something like this. Okay, now let's see what is the next step will be. Yeah, so I have to find limit of this thing. I have made this as n to by a minus 1. This is the whole thing, so n square a plus n plus 1 by 2. So this thing, if I separate it into two parts, so this will be my first part. So what I am doing, I am taking this n square common outside. So when I take n square common outside, what I will have here, a plus half will be my one term, plus I was having this n by 2, so that will become 1 by 2 n. So this will become 1 by 2 and it should be written here. Okay, because I have taken n square common outside. Why I have taken it outside? So that this becomes n to the power a plus 1. And what is the advantage? The advantage will be I can use this n to the power a as part of this thing, 1 by a plus n to the power a, and then I will get a 1 extra n. So this I can use as my dx in that indefinite integral summation formula. So this whole thing will become x and this will become dx. So I will come to it in next slide. So ultimately what it has become, so I have broken this whole thing, this fraction, into two parts. First part is this, and second part in numerator there is 1, because there will be no n square here, because n square I have taken common outside this side. So this is a plus half plus 1 by 2 n. Let's remove this n. So ultimately this limit L will be product of these two limits. This, let's call this one as L1 and this 2 as L2. Now what will be my L2? L2 will be 1 by a plus half. Why? Because as n tends to infinity, 1 by 2 to the power n will go to 0. So this term will go to 0. So I will have my L2, this limit, as 1 by a plus half, that is 2 by 2a plus 1. So this is very neat and clean, this L2. My basic worry and my only problem is how to find this limit L1. So let me find this also. Yeah, now this limit is 1 to the power a plus 2a plus divided by n to the power a plus 1. So I can write it as 1 by n. That's what I had taken, this n to the power a plus 1. So that one of the n I can take it outside. Now this will be 1 by n to the power a plus 2 by n to the power a plus like this. So this is summation k is equal to 1 to n, k by n to the power a, and this is 1 by n. So when this is my summation, this is my first term, that L1 term which I have to find. This will be summation k is equal to 1 to n, k by n to the power a divided by 1 by n. Now when I take limit n tends to infinity here also, and limit n tends to infinity in this also. Now what will be this become? This I can write it as this thing, integration from k is equal to 1. So this will give me lower limit 0, k is equal to n, so this will become 1, k by n I can write it as x to the power a, and 1 by n will become dx. So this summation I can write it in the form of definite integral. So 0 to 1 x to the power a dx, what will be that? That will be 1 by a plus 1, x to the power a plus 1 will be 1 by a plus 1. So this is my limit L1. L2 had used this thing. So L1 into L2 is 1 by 60 is given in question. So this will be a quadratic equation, and the value of a will be 7 and minus 17 by 2. Now most of the solutions which I have seen online and in some books also, they are taking both as correct answer, and in fact this is a trap in this question, because both have been given as correct option. But you see, can your a take the value minus 17 by 2? Just think, it cannot. Why? Because moment say it takes the value minus 17 by 2, what will become of this integral? This will be something like x by to the power a is minus 17 by 2, so this will come in denominator 17 by 2 dx, 0 to 1. Can you integrate this thing? It is very difficult to integrate it, because the moment your x reaches this lower limit 0, this function will blow up, this will go to infinity. Okay, so this value of a is equal to minus 17 by 2 is not the correct answer. I can give you another reason also. You see this term, x to the power a dx, all of these terms are positive. X to the power a dx is always positive for x lying between 0 to 1. So your LHS is positive. Okay, so that is my 0 to 1 x to the power a dx. X to the power a is positive for 0 to 1, so this whole thing is positive. Okay, now what is your RHS? RHS you are getting as 1 by a plus 1. Now for a is equal to minus 17 by 2, this will be negative. So your LHS is positive, this RHS is negative, so this cannot be satisfied for a is equal to minus 17 by 2. So the only correct answer of this question is a is equal to 7. In fact, for a less than minus 1, it is not possible, because the integral does not exist. You cannot find the integral. Okay, so that's why the correct answer in this question will be a is equal to 7.